Good morning. Today we are going to be discussing locating integers on a number line. This is pre-algebra, some very introductory Algebra 1. But first, can you tell me why the chicken, when she was crossing the road, she stopped in the center? Well, she wanted to lay it on the line, of course. So, having said that, what exactly is a number line? Well, a number line is a graphical representation of just a simple point. And what you do when you're going to make a number line, you draw a straight line, you put arrows on the end, and you make marks that are equally spaced. If you were actually doing this on homework paper or being very precise about it, you'd use a straight edge and a ruler, and you'd make sure that these spaces were equally divided. We're going to pick an arbitrary point in the middle of the line, and that's going to be the location of our 0 point. Every number that is to the right of the line is going to represent a positive number. Everything to the left of this number line represents negative numbers. When you're just setting up a standard number line, not a specialized number line, you're just usually going to make increments of, single-digit increments. You go one space to the right on the number line, that's 1. 2 spaces to the right be the number 2. 3 spaces to the right would be a number 3. And you notice that we're increasing in a positive direction as we go to the right on the number line. Similarly, 1 space from 0 on the number line to the left is a -1, -2, -3, -4, and so forth. And what we have when we see these arrows on both sides of the number line, that indicates that this line goes on forever in the positive direction. This sequence of numbers goes on forever in a negative direction, because that's something that you know about numbers. There is no highest number, because no matter what number you come up with, all I have to do is add 1 to it, and I have a larger number. You can say 9 bazillion gazillion 502. Well, if I say 9 bazillion gazillion 203, then that's a larger number. So we say that a number line extends in both directions towards infinity. And there's a symbol for infinity, but you won't learn that for another couple of math classes. So it's really positive infinity and negative infinity. And that's another way of how we see a picture of God in math, because just as God has no end, no beginning, He's in the midst of eternity. He is never ending, never changing. So our number line is infinite. Never ends as it goes forward, never ends as it goes backward. Now, what do we do if we want to locate a number on the number line? Well, it's a very simple thing to do. Let me erase my little step marks here and say we have these 2 problems that we want to solve. A graph 1 on the number line, and then we also have graph -2 on the number line. Things like this are very, very simple to do. You sketch a graph of the number line, or maybe you've already got it written out in your homework or on a worksheet that you have. You locate where +1 is, and you put a solid dot right on the 1. This would be the graph of a +1 on the number line. Similarly, negative numbers, remember, extend to the left of the number line. So we're going to count 2 units from 0 in the negative direction. 1, 2. Sure enough, there we have a -2 on the number line. You simply indicate that with a solid dot. Now you might think, well, what happens if instead of graphing 1 and graphing a -2 on the number line, our instructions said to graph 100 and then to graph a -200. Do you see any difficulties there? Well, let me draw my lines back in here, and then I'll show you the difficulty that I immediately see. Oh my goodness. 1, 2, 3, 4, 5, 6, 7. Positive 100 is going to be in the next room, and -200 is going to be out my front window. So you do not have to have on your number line a sequence that just increases or decreases by 1. And I think it's going to be easier for me to just redraw this number line. Remember, we're going to pick an arbitrary location. It's about in the middle, and that's our origin. Since we're graphing in multiples of 100, I'm just going to do this. 100, 200, -100, -200, and then I'm going to put a -300 in here. And our problem is taken care of. We can graph 100 on the number line very easily. We graph the point -200 on the number line easily. What you need to do is make sure that your units are consistent. Like we couldn't, if this space right here represents 100, then this would have to be another 100, which brings us to 200, another 100, which brings us to 300. You can't say 0, 1, 750. See what I'm saying? It has to be even spaces. But that's really all that's involved in graphing a point or a number on the number line. Now, does the number line always have to be horizontal like that? Well, no. I can think of something immediately where we have our number line running in a vertical direction. So while I finish erasing this, why don't you go ahead and think, what could possibly be a number line that runs in a vertical direction? Well, what if we had something that looks sort of like that? As soon as I draw that, and you see why I teach math instead of art, you know exactly what I'm doing, don't you? There's 0, 10, 20, 30, 40, and my numbers aren't working really well, so I'm going to say 0, 20. Matter of fact, what's nice about having this erasable board is that I can start over. Say right here, 0, 20, 40, 60, 80, and up here at the top, I'm going to put 100. This line right here, I'm going to put a -20. And what I've done here is I've drawn a very crude representation of a thermometer. We have our red colored substance in here, which used to be mercury. I'm not sure what it is now. And according to what level it comes up to, that tells us how hot it is or how cold it is. Now I'm in Texas, and right now, as I'm doing this, the temperature is supposed to be somewhere over 100 degrees today. So I'm going to guess that right now, early in the morning, our temperature is 80 degrees. But the thermometer, it's just the number line. In the vertical direction, going up, is positive numbers, and the further down it goes, that's a negative number. So these vertical number lines are used for thermometers to measure temperature. Sometimes they're used to record giving, like you're saying, okay, we're trying to raise $100,000 for a new building at the YMCA or something. And this will record your giving. So that's all a vertical number line is. Now there's one more thing that I want to talk about, and that would be finding the midpoint of a line. Now, if you hear the term midpoint, what do you think? Let's just see, what could midpoint possibly be? Let's say that over here is home, and over here is church. Here's home, and here's church. And this is the path that you travel to get from home to church. What do you think midpoint is? Well, sure. Midpoint is the middle point between the beginning, or the start, and the ending. So that, let's just say that it's 10 miles from your home to church. So the midpoint of that distance is going to be 5 miles. Once you get to the 5 mile point, you're halfway there, or you're at the midpoint of that line segment. Now, there's a way that you can calculate this. It's a very simple way, using a number line. And the text that I'm using as a reference for these lectures is Bob Jones University Press, Algebra 1, 2nd edition. And if you have that, on page number 4, I'm going to go ahead and sketch the number line that they have here. Whoops. And they did 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I do want you to notice, as I'm sure you have, this is not a nice, neat line, but just for purposes of teaching and explaining, you should be able to see exactly what's going on. And you also see that I've started with my 0 right here. I'm not showing negative numbers, but you can adjust your number line. You don't always have to have the same number of divisions on the right as you do on the left. Their question says, their statement on page 4 says, two numbers, when plotted on the same number line, define a segment. The coordinate of the midpoint of this segment can be found by averaging the coordinates of the endpoints. For example, the midpoint between 4 and 10 is found by averaging 4 and 10. So, that might sound like some really fuzzy math language. So, this is all you have to do. They're going to say find the midpoint of 4 and 10. Now, if you actually want to see this graphically on a number line, you would say, okay, where's 4 located? You've got your dot on 4, and that means it's the coordinate right here, the location of 4 and the location of 10. That means that you're plotting the coordinate of 4 and 10. And our book tells us that to find the midpoint of this line segment, you take the average of these two numbers. And you'll remember that the way you find average is by adding the numbers together and dividing by the total number of digits that your total number of numbers that you're averaging. We're averaging 2 numbers, we're going to divide by 2. So the average is 14 divided by 2, which of course is 7. Now let's see if 7 really is the midpoint. We're saying that 7 is the midpoint. How many units is it from 4 to 7? 1, 2, 3. 3 units. And from 10 to 9, 1, 2, 3. So it's 3 units to the midpoint from the left and from the right. So you can see a picture of that on the number line if that helps you. And that's all that's involved in plotting numbers on the number line, calculating your midpoint, recognizing that number lines can be vertical, they can be horizontal. You want to remember that the further you go towards the right, the higher the number is, the larger the number is, and it's positive. The further that you go in the left direction, it's negative, and actually the smaller the number is. Remember that with negative numbers, let's say if I do this, that means that I've got a break in the number line. If I have negative 2,000 clear over here, which is bigger, 5 or negative 2,000? Well, even though if you look at 2,000 by itself and think, oh, that's bigger, it isn't. The larger the negative number gets, the smaller its actual value is. Think about owing your mother $2,000. I can't imagine that, but owing your mother $2,000, or having $5 in your pocket. Which would you rather have? Would you rather owe someone $2,000 or have $5? Well, of course, you'd rather have $5. So the further in the left direction you go, the smaller the number. The number represents infinity because you can always come up with a larger number. You can always come up with a smaller number. And that's a representation of God. He's infinite. He has no ending and he has no beginning.